Okay, we got lesson 6.3. Tests for parallelograms. So we're sticking with our parallelogram theme in this lesson. And for our warm-up, we have a couple parallelograms here, and it asks us to find the missing variables. Okay, we talked about all these like special characteristics of parallelograms. What is one thing that's true about the opposite sides in parallelograms? They're congruent. What's the other thing?
Parallel.
They're parallel, right? Those are my two things that's true about the opposite sides of parallelograms. So in this case, if I'm trying to find x, I know those opposite sides are congruent. So just set them equal to each other and solve for x. I got 7 for x. Okay. Since x were labeled as like my opposite sides there, that's how I'd solve that. What do we know about their diagonals? You remember? What's special about their diagonals? You know,
They meet at midpoint.
Good. Nice. They intersect or they meet at, I like that, the midpoint. They intersect at the midpoint. They bisect each other. Okay? So here's my blue diagonal. Here's my green. Oh. Here's my green. The two diagonals here. And I know they bisect each other, or like Alejandro said, they meet at the midpoint. So I know those two pieces are going to be congruent, and same on my blue. I know the y plus 8 is going to be congruent to the 4y minus 19. So if you do that, I got y to be 9. Okay, so then to find z, again, that's on my diagonal, so I know that 2z plus 3 is going to be equal to 37, or the same as 37. And I got z to be 17. Okay, like that problem, good review over the characteristics of the opposite sides and the characteristics of the diagonals. Number 2, good review over the characteristics of the angles. All right, there's 2 kind of like characteristics for angles. Who can give me one of them? Alex?
It would be the ones like on top equal to 180.
Good. Yes, these 2, any consecutive, add up to 180, or these 2 as well, like this one and this one. So did you do the 3x plus 1 and the plus that equals 180?
I did the 107 plus y equals 180, and then the y is equal to 3x plus 1.
Beautiful. I did that too. So I'm going to put dots here because they're not congruent, but these add to 180. So this is beautiful. I did the exact same thing. I did this plus 107. It has to total 180. So that's 73. So y is 73. Okay. So that's true about consecutive angles next to each other. What do we know about opposite angles in a parallelogram? They're congruent. You need a shout out. They're congruent. So to find x, I know that has to also be 73 degrees. So x is 24. Okay. Nice. That's right. And then we have this graphing one. Okay, I'm going to go ahead and plot this parallelogram. So they tell me QRST is a parallelogram, -2, -1. At these vertices, -3, 6. 1, 5. 2, -2. Okay, that was not my best drawing. What they want us to do is find the coordinates of where the diagonals intersect. Okay, so you can use a straight edge and draw on your diagonals. Now, it's not sufficient enough to just guess where they intersect, like some of you guys try to do on the take-home test. It's not sufficient just to look at this and be like, that looks like negative 1, 2-ish. All right, you got to calculate exactly where it is. And it's not that hard. Since we know, like Alejandro said, that they intersect at the midpoint, all you got to do is find the midpoint of one of those two diagonals, and that's going to be where they intersect. So I picked QS. You could also do RT if you want to, but remember to find the midpoint. I'm doing this one. Add the x coordinates and divide it by 2. That's going to give you halfway between the x coordinates. Add the y coordinates. Divide by 2. That's going to give you half of the y coordinates. So you'll notice here we get negative 1/2, 2. And then I look at my drawing, and again, you can see that my sketch was pretty rough, especially my parallelogram. Negative 1/2, or negative 1/2, 2. Yeah, that looks pretty close to where those intersect. And the better you make your drawing with your straight edge, the more accurately you're able to like check your answer there. So all you got to do is find the midpoint of either side. You don't even have to find it on both. If you want to check your work, you can, but you don't have to. Questions on the warm-up, my friends? Let's review over 6.2. So I like this lesson because it's kind of like an extension of our discussion with parallelograms. Parallelograms are so fun. There's so many like cool characteristics about them. So basically, in these problems I told you, they were parallelograms and you apply their characteristics to find some missing sides or missing angles. Now we're going to go backwards, where I'm going to give you some side lengths and angles, and you're going to determine, does this fit the criteria of making this a parallelogram? All right? So there's a bunch of different ways we can prove something's a quadrilateral, or we can prove that a quadrilateral is a parallelogram. First, we could show that both pairs of opposite sides are parallel. So this side is parallel to this side, and this side is parallel to that side. If we can show that, then we can conclude it's a parallelogram. That's what a parallelogram is. The other thing you could do is you could show that both pairs of opposite sides are congruent or are the same length. If you can show that, if you can show these two opposite sides are congruent, and so are these two opposite sides, then you can conclude it's a parallelogram. Okay? Remember, a rectangle is a type of a parallelogram. Another one, this one's kind of fun. If you can show that just one of the pairs, or both of those, are both parallel and congruent, that's enough to justify it's a parallelogram. Because if you have two side lengths that are parallel and are the same length, the only way to finish making that polygon is by making another set of opposite sides that are parallel and congruent. Okay, so again, if I have two sides like this, they're the same length. Those don't look super the same length, but parallel. The only way I can make this shape is by making another pair of congruent parallel sides. There's no other way. Okay. We could also show that both pairs of opposite angles are congruent. So we know that's one of our characters of parallelogram. So the opposite angles, we got to show both though. We can show that. Or last case scenario, we can show that the diagonals bisect each other, meaning they cross at the midpoint. If we can show that, then we know it's a parallelogram. Okay, so it's basically all those properties that we already know, and now we're going to use those properties to determine if a given quadrilateral is a parallelogram. The only other thing I want you to add to your notes here is sometimes to show opposite sides are parallel, we're going to have to find their slopes. So just put that note right now. Because if I can show that two sides have the what kind of slope in order to be parallel? Parallel lines have what kind of slopes? The same. Yep. You can show that the slopes are the same. You can show the opposite sides are parallel. To show that both sides are congruent, if we're talking about length, you might have to find the distances using our good trusty friend, the distance formula. Okay. That's what I want you right there. Let's try some. Determine whether the quadrilateral is a parallelogram. Justify your answer. So there's no markings on this first picture here. There's no like parallel markings. There's no congruent markings, but they're telling me the length. This side's 35. This side's 35. Those are congruent. This side's 20. This side's 20. Those are congruent. Is that enough to justify this as a parallelogram? Yes, by that second criteria. Both pairs of opposite sides are congruent. Yes. Does say justify, so you'd say both pairs of, I'm okay with you abbreviating opposite as this, OPP. I'm also okay with you doing the math symbol for congruent if you don't want to write it out. I like using the math symbols. Both pairs of opposite sides are congruent. Good. Okay, this next one's really hard to see. I know it's really small on your printed out version here, but can you kind of see those little tick marks by the 15? Kind of. Those are actually arrows. You can see it better on my board here. These are actually, they're showing you arrows. What do those mean? Parallel. On my other side's parallel? We don't know for sure, so we assume no. But we do know that the set of parallel sides are also what? Congruent, 15 and 15. So they're parallel and they're congruent. Is that enough to justify this is a parallelogram? Yes, by this one right here. If you can pick one pair and prove both, parallel and congruency, then it's going to be a parallelogram. Yes. A pair of opposite sides are, okay, you know how to use this for perpendicular? If you want to use this for parallel, you can. Or you can write out parallel, it's up to you. Just don't get that confused with an 11. A pair of opposite sides are both parallel and congruent. Let's try a couple algebra ones in here. I need to start throwing more ones with fractions in our notes for practice. Sheesh. Throw 1/2 in front of an x and you guys freak out. Change it to 0.5 if you need to. At this point. All right. Find x and y so that the quadrilateral is a parallelogram. They're showing me side lengths. And if I'm looking at the x's, they're located on opposite sides and so are the y's. So if I can show that both pair of opposite sides are congruent, that would make this a parallelogram. So I want to figure out what x would have to be for those to be congruent. So let's just set them equal to each other. Okay, let's go ahead and solve this. Okay. If x is 7, and you can check your answer, go back and plug it in. Those sides are going to be congruent. Those sides are going to be the same length. I have no way of like showing that they can be parallel. I can't really find the slopes here. It's not on a coordinate plane. So the only other thing I can do is show that the other sides are congruent as well. That both pairs of opposite sides are congruent. All right, that would have to be 5 for y in that case. Okay, so those would be the solutions there. That would give me both pairs of opposite sides being congruent, which would make it a parallelogram. Let's try one with angle measures. Find x and y so that each quadrilateral is a parallelogram. Okay. So if I can show, for angle measures, that both pairs of opposite angles are congruent, then it's going to force this to be a parallelogram. So look at my opposite pairs here. So I have 56 and 7x, so x is easy to find here. X would have to be 8. And I have to show these angles are congruent. So y would have to be 30. Okay, not too bad. All right, you guys do this one. We did one almost just like that. So I'll give you like 1 minute. Find x, find y. Okay, I got x to be 3, y to be 7. Good? Okay, this next problem is like a cute little problem. It's fun. For quadrilateral ABCD, the slope of AB is 2/5, the slope of BC is -3/7, and the slope of CD is 2/5. Find the slope of DA so that ABCD would be a parallelogram. I know a lot of you could like quickly do this in your head, and that's great. And maybe some of you are thinking, well, what the heck, I need a coordinate plane to do that. You don't really. We can just draw like a little sketch if we want to. Again, I know a lot of you could do it very easily, but let's go ahead and draw a parallelogram. Doesn't matter where you start. If you want to start with this A or this A, it doesn't really matter, but you gotta go in order. So A, B, C, D. Okay, here's what we know. We know the slope of AB, which is this one right here, is 2/5. So this has a rise of 2 and a run of 5. My picture is not super drawn to scale here. Looks like it could be 5/2, but not 2/5. And the slope is rise of 2, run of 5. At least it's going in the right direction, I guess. We know the slope of CD is also 2/5. I'm using M because I don't want you to think it's a distance of 2/5. It's telling you the direction and the steepness of that line. That's what slope is. Okay. All right. We know that BC has a slope of -3/7. So what they want us to figure out is what the slope of this line segment would have to be in order to make this a parallelogram. Now, before you start on the answers, what do we know about these sides? They're not congruent. They're parallel because they have the same slope. They're parallel. They have the same slope. Okay, we don't know anything about their lengths. So in order to make this parallelogram, I want to figure out what the slope of my green side needs to be so that these are also parallel. So what would the slope of this side have to be? -3/7, exactly. And you're like, oh yeah, gotta figure that out without a picture. Totally fine. Visual's good. All right, we're gonna do a couple problems where it is on the coordinate plane or parallelogram. All right, so this one says quadrilateral QRST has vertices at those 4 locations. Determine whether the quadrilateral is a parallelogram using the slope formula. Okay, I'm going to highlight that part because this might be different in the different problems you do. So this one says using the slope formula. It could say use the distance formula. It could say use both. So just pay attention to what they're asking you to use. Okay, let's go ahead and plot that quadrilateral quickly. So -1, 3, 3, 1, 2, -3, -2, -1. Okay. All right. So using my slope formulas, what do I have to show here? What are we trying to do? Okay. What sides? What are you saying? Go ahead. Both pairs of opposite sides. So we're going to have to show like QT. QT, that's my favorite line segment. QT and SR, we're going to have to show those are parallel. How can I do that? Find the slopes. If they're the same slopes, they're parallel, right? All right, let's start with QT. Now, you can count rise over run to calculate slope, although I realized after the semester exam, some of us need practice with our slope formula too. But you can calculate rise over run, or you can do the slope formula. 3 minus -1. Now, before I get a final answer, should I be getting a positive or a negative number for that slope? Positive, right? It's rising left to right. So you can see here I have a rise of 4, run of 1. QT has a slope of 4. All right, let's check SR. So you can count rise over run. I'm A-okay with you doing rise over run. If you like slope formula, that's fine too. Hey, that one also has a slope of 4. We just showed those are parallel. Now, Gwen said we have to show both sides. And she's right. If it asks us to use slope, they want us to show that both sides are parallel. So we're going to do the same thing for QR and TS. Okay. Before I get a final answer here, should I be getting a positive or negative number? Negative. It's going down left to right. And I get -1/2, and that makes sense. I'm going down 1 over 2, down 1 over 2. All right, TS. I see. I also get -1 over 2. All right. We just showed both sides are also parallel. So to answer their question, determine whether the quadrilateral is a parallelogram. Yes. It is a parallelogram. Since QT is parallel to SR and you can show both sides, QR is parallel to TS. All right, so they ask you to use slopes, and we made this note back here. If they ask you to use slopes, they want you to show that both sides are parallel. All right, one more, folks. You're good. This one looks similar, in which they give me this coordinate plane, they give me the vertices of the quadrilateral. But this time, notice how the directions say determine whether the quadrilateral is a parallelogram by using the distance and slope formulas. Okay, don't worry. Watch what happens when we plot this. You'll like this. 0, 1, 4, 4, 12, 4, 8, 1. Okay. So if I have to use distance and slope, I'm basically going to try to do this right here. I'm going to pick one pair of opposite sides and show that they're both parallel and congruent. Okay, so I don't need to do it for all 4 sides. I just need to pick one pair of opposite sides, show they're parallel, show their distances are the same. What 2 sides should we pick, Ben?
BC and AB.
Oh, love it. Let's pick the nice, easy horizontal ones. Because guess what? We don't even need distance formula to calculate that distance, right? We can just count our squares. I'm telling you guys right now, though, they're not all going to be set up this way. Okay? But our first step here to be find the length. So I'm going to write this out in case you have to use distance formula. Find the length of a pair of opposite sides. Here's my note to myself. So if you chose like these ones, you'd have to use distance formula. Or you could draw in our little right triangle here. You could use Pythag and do this squared plus this squared equals that squared. That's the same as distance formula. The distance formula is Pythagorean theorem rearranged, solved for the hypotenuse. May need. I think there's one on your homework where you have to do distance formula. Okay, in this case we don't, because Ben decided to use the nice, clean, horizontal sides. So how long is BC? What's that length? 8. Good, 8 units. What about AD? 1, 2, 3, 4, 5, 6, 7. Also 8 units. So we just showed those are congruent. They're the same distance or same length. Now we just have to show they're parallel. So then you're going to find the slope. Of the same pair of opposite sides. Who can tell me what the slope of a horizontal, raise your hand, of a horizontal line is? What is the slope of a horizontal line? Walker, you gonna do it?
0.
Nice! 0! 0! I thought you raised your hand, did you?
No.
Or you were waiting
He
for Alejandro?
Yeah, he did.
Yeah, I saw back there he went like
Yeah,
this.
he raised his hand.
Oh, you were just waiting?
Yeah.
Or you
No,
were
he-
signaling only 5 more minutes?
No.
Oh.
Signaling like the answer is 5.
Oh. All right. So, folks, is this parallelogram?
Yes.
Yes. It is a parallelogram. Since BC is equal to AD, they're both 8. And they're parallel. That same set of sides are both congruent and parallel. All right, I got a couple things I need to give to you.